The position of a particle moving in the xy plane is given by the parametric equations x of t equals 6t over t plus 1, and y of t equals negative 8 over t squared plus 4. What is the slope of the line tangent to the path of the particle at the point where t equals 2? So our first step is to find the slope, which is d of y over d of x. So that means we're going to have to differentiate both y of t and x of t. So when we take y of t, we can manipulate this to where it's negative 8 times t squared plus 4 to the negative 1. Then when we use our rules, we know negative 1 times negative 8 is 8 times t squared plus 4. Subtract this by 1, we get negative 2. Then use the chain rule. We're going to differentiate the inside, which gives us 2t. And that is our y prime of t. Now we're going to differentiate x of t. We're going to do that by using the quotient rule. So low d high minus high d low over low low. Now we're just going to divide d of y by d of x. So we're going to get 16t, 8 times 2 is 16, over t squared plus 4 squared. Then when you divide by this, we're just going to multiply by the reciprocal. So that's t plus 1 squared over, this ends up being 6. So now that we have our d of y over d of x, we don't need to simplify anymore because we are looking for the slope at the point where t equals 2. So all we have to do is plug 2 in for t. And when we do that, we end up with 32 over 64 times 9 over 6, which also equals 1/2 times 3/2, which gives us 3/4, which is our slope at the line tangent to the path of the particle at the point where t equals 2. And that is how you find the first derivative of parametric equations.